This talk is going to be on secure feature development for Android with Gradle, DEXGUARD, and Google Cloud Test Lab. So Ticketmaster is the world's leading ticket company with 530 million ticket transactions in 2015 across 22 countries. And that makes it one of the world's top 10 e-commerce sites. I'm going to go over a lot of stuff in this talk today. So keep in mind, some of these are more advanced features of Android, so you might not be familiar with some of them. Other parts of it, you might be more familiar. So I'm going to try to stay pretty high level. I'll show a little bit of code, but not too much. So this is kind of an introduction to some more advanced areas of Android development that I think if you haven't worked with these before, you might find this very useful. First, we're going to talk a little bit about security in Android. And specifically, we're going to talk about using something called DEXGUARD for Gradle builds for Android. We're going to talk about new feature development. In particular, at Ticketmaster, we have a new feature called our interactive seat map. And we're going to talk about how we built it using the native developer kit, MDK for Android, and the Gradle experimental plugin. Finally, we're going to show a little bit about how we tested this new feature using the Google Cloud Test Lab. And we'll end with giving you a little introduction to some of the open source tools available from Ticketmaster. So 2015, this is last year, Ticketmaster, we had a very big year, our biggest ever. Some huge concerts and events went on sale. Here's a small sample of them. We had the Grateful Dead farewell tour. Last time, most of the original band was actually playing together in concert. Mayweather vs. Pacquiao, biggest boxing fight ever. Only about 400 tickets went on sale. And Adele had a giant North American tour, concerts across every time zone in North America. And so some huge events. I was on the Android team at the time, and we like to think of our Android app as kind of a small concert venue. We're trying to handle all this new traffic coming from desktop to mobile. Like most companies, we've seen huge growth in our mobile applications. A lot of traffic is moving away from traditional desktop website into mobile. So how do we handle all this new traffic? It becomes a very challenging problem for our mobile applications. And on the Android team especially, we had some specific challenges to deal with. I'm going to talk a little bit about security. So security in Android is a topic that you see covered very lightly, but not in too much depth at a lot of sites. So I'm going to go into a little more depth on security for Android today, and some extra layers that you can add to your application. I like to think of security as layers because there's really a never-ending cycle of hardening your application that you can provide. And the more harden your application, the more layers someone who's trying to reverse engineer your application is going to have to get through. So the first layer for security in Android development is just what we call core design. So this is a lot of just basics of Java. Things like strong encapsulation of your classes, making your methods private unless you absolutely need things to be public. Don't store passwords in plain text. These kind of basics of Java best practices for security that take place not just in Android, but really across all languages and development environments. One of the big no-nos is unless you're really an expert, don't spend time writing your own encryption. Use what's already out there. In almost 99% of cases, it's going to be much better than anything you can come up with yourself. And in fact, a lot of times you're doing yourself damage by trying to roll your own encryption strategy. So that's a big no-no in terms of core design. There's more information you can find in some of these textbooks that I've included on this slide. These are some of the best-known security primers for Android. So if you want more information on core design, these are really good places to look. Now the second layer of Android security is the networking layer. So most Android applications are going to have some sort of interaction with a web service. And so Google recently has done a much better job explaining these and giving us some best practices. So this is just the website where you can find this now on Android. For a while, it was harder to find documentation on this, but I think they've realized now as a community that they need to do a better job explaining best practices, showing you how to prevent the most common types of exploits. And so obviously the basics of the networking layer nowadays are going to be TLS and HTTPS encryption on all of your networking. So this is going to make sure that all of your data coming into and out of your application over a web service is going to be encrypted correctly. And there's lots of best practices around this. Google is now even notifying developers who may have made a mistake in their implementation. You might get an email saying you're overriding a certain method that you should not be overriding. And so they're really taking a lead on this to make sure that applications are implementing all the best practices. And so a lot of Android developers get through these first two, and they probably assume they're done. Unfortunately, there's a big problem in the Android community that because of the way the Play Store works and because of the way Android applications can be distributed, there's unfortunately a lot of other things that can be done to secure your application that aren't well documented. So I'm going to go over a few of those right now. So again, if we think of this as kind of like a venue, imagine if we only had one security guard in the front of our venue. It'd be probably a pretty bad security policy, because if they find another way to get in, you're going to have no security there. And what tends to happen with security is malicious users are going to try to find the path of least resistance. So you may have great network security. They'll just go around it. They'll find a way to get into your application and go after your sensitive data without trying to break into your networking layer. So whatever's the easiest way, that's what they're going to target. And that's true of anything. Obviously, you're going to find the path of least resistance. So what you don't want to do is create a simple challenge. A lot of times people are going to, especially if there's value to what you have inside of your application. With Ticketmaster, our tickets are obviously very valuable. If you can get access to them before other fans, then you have a huge advantage. So no matter how difficult the challenge is, if it's valuable, people are more likely to try to find a solution. So I want to talk a little bit about DEXGUARD. If you're an Android developer, you're probably already familiar with ProGuard. ProGuard is also just used in Java development in general. And luckily for us, there's another tool called DEXGUARD by the same company. Both of them are made by GuardSquare. And what DEXGUARD is it's an extra layer of security for Android. So it uses a lot of the same configuration style that ProGuard does, but adds some extra layers of security onto your application. So here's a quick example of a Gradle configuration for DEXGUARD. So just like usual, you're going to specify, in our case, we're using a library folder, so we have to specify it as a flat directory. We're going to add our dependencies, and we're going to apply the DEXGUARD plugin. Now what happens, once you apply the DEXGUARD plugin, you can specify a DEXGUARD project file in the very same way that you would apply ProGuard to your Android application. So you're going to specify a text file. In our case, we're actually using both still. We have a ProGuard file and a DEXGUARD file. You don't have to do it that way. You can actually combine all of your ProGuard arguments into a single file. But we like to keep it separate, because that way, if we need to remove DEXGUARD for any reason, we still have all of our standard ProGuard configuration in a separate file. So let me show you some of the extra things that DEXGUARD can do for your Android application. So there's a command to encrypt assets. So let's say you have an asset folder filled with XML files or text files or configuration files. This is a one-line command to encrypt them. It's also possible to encrypt classes specifically. So in this case, I'm telling it to encrypt my Hello World activity. So I talked about those layers earlier, and the first two. Let's go through some additional security layers that DEXGUARD recommends as part of best practices. And these are extremely easy to configure if you're using DEXGUARD. So there's string encryption. There's something you can use reflection. I'll go into a little more detail about how you use these with DEXGUARD. Code obfuscation, removing logging code and stack traces, tamper detection, environment checks, asset encryption, I just showed you an example of that, resource encryption, native library encryption, and class encryption. So let's look at an example of how do you do string encryption. This is really useful for things like, let's say you have an AWS key or some value that you need to have hard-coded in your application, but you don't want it to be out there. If you've looked into how reverse engineering works in Android, really what happens is they're going to take your APK file, they're going to reverse engineer it into the Java bytecode, and they can do really quick lookups of your string table. So any kind of private, even if they're private, it's going to be very easy for them to find all of your string values. So encrypting your strings, in this case I'm encrypting a string named secret key within a constants class. It's going to make it more difficult for them to find these values. There's also a way to just encrypt every string within a class. So in this second example, it's using the encrypt strings argument to tell it to encrypt all the strings within a particular class. Reflection. So Java developers, you might already be familiar with how to use reflection. What DEXGUARD can do is actually replace certain invocations by reflection and then encrypt the result. And so that way it's really difficult for people trying to reverse engineer your application to figure out using static analysis. So here's an example, again, in your DEXGUARD configuration file, where it's telling it to access through reflection the secure random class and which methods within that class to access through reflection. With Java reflection, there is a little bit of a performance cost, so obviously you don't want to do this everywhere. But for certain methods that you want to add some extra layer of security on, this is a really useful thing that DEXGUARD makes very easy for you. And what they recommend is that you combine reflection with string encryption. So basically, in this case, it's doing both. You're telling it to access through reflection these two methods, and then telling it to encrypt the resulting strings within that method as well. So that's just going to make it more and more difficult when they're trying to reverse engineer this. They're going to have to dive through so many layers of encryption. You're just adding more and more things that they have to figure out. Code obfuscation. ProGuard out of the box adds a little bit of code obfuscation on its own, but DEXGUARD has a much more sophisticated way of doing this. You can specify a strength modifier, for example, high strength, medium strength, low strength, and you can do it at a class level. So for example, you can mix and match how strong obfuscation you want to use on different classes or packages. Runtime environment checks. So going back to our event venue example, while the event is going on, while the application is running, a lot of times you want to check and make sure everything is as it should be. So some examples of some runtime environment checks that DEXGUARD allows you to do is tamper detection. So tamper detection is to make sure that the application hasn't been repackaged, new files haven't been added to it, code hasn't been tampered since you built it and released it on the Play Store. And you can do this using, in this example, this check APK method, the tamper detector. And what's nice about it, it's getting a little bit cut off, but it returns an integer value. So what that allows you to do is actually mix this into your code. It doesn't just, for example, cause your application to fail. It gives you an integer value that you can do something with. And what DEXGUARD recommends is you kind of work this into your application so that it fails silently. When people are trying to reverse engineer your application, they're going to run it multiple times, and they're going to try to figure out why it's failing. And if you make it really easy for them, if there's a single point of failure, if you're using something like a debug config to enable or disable certain features, they're going to find that weak point and just set that value to true. So it's a lot more effective if you mix it into your code, and then they recommend further hardening it by then encrypting the classes where you're actually doing this. So now you're adding runtime environment checks, you're encrypting that class so that when you convert this to bytecode using reverse engineering tools, it's going to look like complete gibberish. They're going to have to figure that out first. Then they're going to have to figure out what the tamper detector is doing. And then they're going to have to figure out how to disable that. So you're just adding more and more difficulty for someone trying to do this. You can test this really easily using the zip-align tool. So basically what you can do to make sure this is working is you just run zip-align on your APK file. And if you have this tamper detector in place, you're going to return a non-zero value for that check. And in our case, we're basically preventing them from loading data if they fail that tamper detection check. There's some other runtime checks you can do, things like whether it's, the application is debuggable. Typically, you don't want your application to be released to the public, allowing it to be debugged. You can check whether a debugger is connected. You can check whether it's been signed with a debug key. you can check whether it's running in an emulator and whether the device is rooted. Some of these features are available in other tools, but DEXGUARD combines it all in one place, so it just makes it really easy to work with. And so we like to do all these checks in our release applications to make sure that people can't take our application, repackage it, run it on a debugger, try to reverse engineer it, figure out what's going on. This makes it really challenging. Again, we try to do this a little bit silently. We don't want to let them know which of the checks failed. You don't want to say you're connected to a debugger. We want to just say fail silently so that they really have to figure out what's going wrong if they're trying to reverse engineer this. Okay, so another thing we do is we leverage some of Google's machine learning. So this is kind of outside of a DEXGUARD scope. This is another good security practice for sensitive applications. We have a way of making sure that it's a human user, and we're using Google's, all of their learning on machine intelligence, their new reCAPTCHA system. Google has made a big advancement. They found that the old CAPTCHAs, which you still see on a lot of sites where you have to type in the letters, the problem with those is that image recognition technology has gotten so good that machines are actually better at solving those than humans. So what used to happen with CAPTCHAs is it was more difficult for humans to solve than for machines. So it was a huge failure. They've come up with a new system where they're using data, things like mouse movement, but they're also using things like advanced image matching and some of their deep learning algorithms, like which of these images contain a turkey. That's something that's a lot more challenging for someone to write their own image recognition system. Google obviously is at the forefront of machine learning, so they're usually going to be ahead of the field on this, and we use them for kind of a last measure before making purchases. And we can turn this feature on or off depending on how sensitive the tickets are. Obviously, when things first go on sale is when they tend to be the most sensitive and the most valuable, so this is a good last step. And Google is constantly making advances in this technology. Hopefully, in the near future, you won't even have to solve anything. It'll have enough data based on your interactions at the front end to know whether you're a human or not. So using these techniques in 2015, Ticketmaster was basically able to completely clear out all of the bot traffic. At the beginning of the year, our server team was telling us that something like 70% of all of the malicious actors who are trying to access tickets at Ticketmaster were coming from the Android application or coming from users who are pretending to be the Android application. And so it's a big problem with Android developer community in general. These devices are very easy to root. It's very easy to oftentimes get unlicensed APK files and break into them. And so we have to, as a community, do a better job of not making Android the target of choice. And by using these configurations with DEXGUARD and Gradle, we basically got rid of all of our bot traffic from Android. And so it's no longer the path of least resistance. They went to other, either they gave up altogether or they went to other sources. So you don't want it to be an easy solution. You want it to be more challenging. And the more layers you add to your security, eventually it becomes this kind of impossible to figure out cycle where it's not worth their time and effort anymore. No matter how valuable your data is, if it becomes something that's going to take them months and months to reverse engineer every time you release a new version, it's not going to be worth their effort anymore. So when people tell you security is kind of not worth your effort, don't listen to them, because we've found from our experience that you can force out a lot of malicious users by implementing more layers of security. Some special considerations. So multi-dexing was a little challenging for us. If you're hitting that 65K method limit in Android, at first in 2015, this was not compatible. The Android support multi-dex library was not compatible with DEXGUARD, so we had to use DEXGUARD's own dex splitting approach, which was a little bit more tedious. You had to specify at the package level which packages to split into a separate dex. But now in 2016, you can just use the Android support multi-dex library. It does it all automatically. You don't even have to think about it anymore. So it made it a lot easier for us to continue using DEXGUARD as we add more and more third-party libraries, as probably most Android developers are familiar. It's very easy to go over that 65K limit, and now that's not a problem for us anymore. We've also been told that it's going to be compatible with the new Jack and Jill compiler and Android N, so you don't have to worry about the future. DEXGUARD is updated on a weekly basis, and they're going to stay up to date with all of the newest tools coming out from Android. So it's pretty much future-proof, at least for everything that we're aware of. One thing to be aware of at the Gradle conference here is you should always profile your builds. So we found that the DEXGUARD step was by far the slowest part of our build process. You can see here it's taking us almost 43 seconds. So if you're not an application that has special security concerns, if this is a school project or something, probably this is not the approach you need. But if you have sensitive, important data, this is a really good step you can take. And there's an extra DEXGUARD task for Gradle that you can use instead of just the Gradle plugin. You can use a task, and that way you can set up a system where you're only running the task before release builds or before store builds. And that way you're not necessarily running it every time you do a debug or a release build. Okay, so I talked a little bit about 2015, which was last year. We made huge updates to our security. Now we're on to 2016. Now we can finally focus on new features. One of the constant complaints that our Android app was getting was better choosing of seating. Could use a better seat map function. This guy says, it just stinks. I'm not able to choose seats the way you can in the desktop. Movie sites have figured this out. What's the problem? So that stings. You'd never want your app to be compared to other apps negatively. One of the challenges at Ticketmaster for getting a really good seat map picker is just the variance of venues. We have over 1,000 different venues in North America, ranging from small, intimate clubs, 30 to 40 seats, lots of standing room areas, to 60, 70, 80,000 seat venues with mixtures of different levels, types of seating, open general admission and reserve seats. So just the variance in venues and configurations makes finding a universal solution to a seat picker very challenging. So we had the challenges to support a wide variety of venue sizes, support a wide variety of devices, and we wanted it to be a consistent experience across both our iOS and Android apps. And so our solution, we call it our ISM, our Interactive Seat Map. I'm going to show you some screenshots. So first of all, let's just compare the experience. I want to show you on the left-hand side, this is our old purchasing experience. You would basically choose how many tickets you want. You would say, what tickets do you have available? Our server would try to figure out using some secret algorithm what it thinks is the best ticket for you, and that's your option. Now compare that to our new interactive seat map, where you can actually zoom in and out. You can look at individual seats, compare prices, decide where exactly within the venue you want to sit, and we think it's a much better experience. A lot of people have preferences, things like sitting at the aisle or being close to some other friends that have already purchased tickets. So all of this was unavailable to our mobile users until we worked on this feature. To do this, we had to use the Android NDK, Native Developer Kit. So this is another advanced area of Android development, which you probably haven't worked with, unless there's some certain reasons where the NDK is really useful. For one thing, it allows you to use native code, C and C++ within your Android app. And the two bullet points here at the bottom are really the only reasons why you should be using it. One, you need to squeeze extra performance out of a device. It's really common in things like games and physics simulations. Or two, you have this library that's already been written in C and C++, and you really want to reuse it. You don't want to have to rewrite something from scratch in multiple languages. And so that was the case for us. It helped us achieve that consistency between our iOS and Android app. We wrote our renderer in C, and we can use the NDK in Android to connect it to our Java code. To do this, you have to work with JNI, the Java Native Interface, which is it's vendor neutral. You want to think of it as kind of like your glue to connect your Java code to your native code. And while it's a little bit cumbersome, a lot of the method signatures are pretty long and complex, it's reasonably efficient. You kind of just have to get over the barrier of just getting used to it. And it's really not too bad as soon as you get comfortable with it. So here's a quick example of what our project might look like. So you can see this is an Android application. You have the familiar main, test, Android test folders. But inside of main, we have a Java directory, and we also have a JNI directory. So it's inside of that JNI directory that all of our native code lives. So we have this ISM renderer folder. That's actually where all of our native C code is placed. And then these two classes, the .h and CPP file, is actually our JNI definition. So this is where we actually take our methods from C and expose them to Java. We're using the Gradle experimental plugin, and the reason why is because it adds IDE support for Android Studio, so that you can actually, first of all, it can detect your JNI methods. It won't throw you that underline red squiggly on it, and also it'll allow you to jump from your Java code into your native code using Command B to just kind of dive into it if you're so inclined. And we found that we were actually able to mix the experimental Gradle plugin with the Android Gradle plugin. So for example, if we have one module that we want to build using experimental, and we have the rest of our modules that we want to keep building using the standard Android Gradle plugin, that works fine. The experimental plugin uses the new model, the new Gradle model, so it's a little bit of a refactoring to get it to compile correctly. And so we were able to just build our interactive seat map module using the experimental plugin. Okay, so now that I've talked about how we actually can build this, I want to introduce Yung Trang, who is another Android developer at Ticketmaster. And she's going to talk a little bit about how we tested this.
So what is Google Cloud Test Lab? It's a cloud-based infrastructure for testing your applications. It provides many different new and popular models, both virtual and physical, for Android device to use to test your app. And you can also do different configurations with different testing framework on it too. So there are 3 ways to start integrate Cloud Test Lab into your application currently. The first way is to use the Android Studio iterations, which is built in, where you can see if the test is passed or failed directly in your IDE. The second way is use their command line interface, which I will show an example later. And the third way is to go on to the web UI, which is also known as developer console. So this is an example of how to trigger the gcloud command on a machine. So here you can see that if you trigger Android device list, you can see the number of devices that they have for you. So you can see they have a number of virtual and both physical devices with different resolution and version of OS versions. And this is after you execute your command, the result will be hosted on the console. And this is what the web interface looks like. So this is the old one. And they just recently announced a new one called Firebase Console. The functionality is the same. It's just the UI interface is different, so you don't have to change much configurations on there. And to trigger a simple test, you can basically use a command like this, where you can define what type of test that you want to run, Robo or Espresso, and then you can define what kind of device. Here is the Nexus 6 and 7, and then versions and different language that you want to test on. And to trigger that command, you can easily integrate it using the Gradle task, and basically just trigger it using the command line. Another useful that useful process that Gradle task can help you is that before you want to compile your application, you might want to modify here and there, maybe a little bit in your code to prepare your APK for the test environment. So here, a simple Gradle task written in Groovy can help you accomplish that. For our Ticketmaster app, we basically just change to bypass some of the code, so we can easily test it on the Google Cloud Test Lab. So here's basically just a Groovy script to change some of the change some of the file. And here you can see a very small demo of how we make that happen. So you run the task, and then it's compile your build. Maybe I want to pass forward this. So here you can see that it's uploading your APK onto the Google Cloud Test Lab. There you go. So, and then it will give you a URL where the result will be streaming to. So, if you click on that URL, this is the Firebase console that they will provide you. In here, you can see that it's running on many different devices. So you can see how the UI of your Android app look like. And it will tell you how many devices that if the test passed and how many failed. And if you go into one of the links, it even shows more details what the test issue is. So it's basically explore and find crashes in your app. It shows you the logs. Slow. Let's try this one. Okay, so it screenshot all your UI. So you can basically see if there anything weird look like on certain device. It's also able to map out all the activity that is able to explore. This is global test, so it's basically just go into your device. And it's also provide you a video where you can see what the test is doing on this specific device. Maybe I can, and it's stored on there too, so it's pretty cool. So you can see loading map. You can see how interactive zip map look like on a specific device that you don't have a physical device on your company to test with. So yeah, so you can see that. Just go back to Keynote. Back to Jeff.
All right, so yeah, Cloud Test Lab has been really helpful with a big feature like the interactive seat map. It's especially with all the fragmentation in the Android space, we have to make sure that it runs, that all of these different devices can support it. So figuring out some of these crashes early on has been a big help to us. This feature is going to be released within the next few weeks. We've already released it on iOS. If you're using the Ticketmaster app, you're going to see that only some events have it enabled. But we're going to unlock more and more over the coming months. By the end of the year, we expect more than 90% of our events will have this interactive seat map feature, so it's really exciting. I wanted to talk a little bit about the developer community at Ticketmaster. So Ticketmaster obviously is a very old company. They've been around since the 70s, but we're trying to grow, be more of a part of the open source world. We have a new portal, developer.ticketmaster.com, and we have some open source tools there, both for Android, for the web, for iOS. We have our blog posts, some of our partners and APIs of other companies we work with. And one of the most exciting areas is our new open platform. So traditionally, Ticketmaster has used a closed API. Only internal developers can hit it. Now we're changing. We're growing as a company. We realize that the way the rest of the world works is that we need to make an open platform that anyone can hit. So we have a new tool called the Discovery API. You can get an API key at that site I just mentioned developer.ticketmaster.com. And this will allow you access to our entire library of events. You can do things like find out when it's playing, when the tickets go on sale, what are the different types of tickets available, what time does it start, what are the different parking options. All this kind of stuff is now going to be open to everyone who has an API key. So if you want to build a Ticketmaster client, or if you want to add some events into your own application, we want to make that possible. This is part of a long-term effort. So right now we've built the discovery part of it. There's going to be a checkout SDK that's coming out this year that'll actually allow you to make purchases within your application. So right now you can kind of only do search and browse through our library, but the checkout portion is also going to be made available to everyone who has an API key. And you can apply for that API key at the site I just mentioned. There's already a Java SDK on GitHub, which has all of the endpoints already mapped out for you. It's using Gradle to build. So if you're a Java developer and you want to play around a little bit with this API, it's a great time to get started. There was a talk just a minute ago about the Gradle open source community. We're trying to catch up to other companies and make sure that it's a really good community where you can make pull requests, you can fork it, you can submit suggestions. We want to know what we're doing wrong. So it's a really good time. This is very early for us. It's a whole new approach for Ticketmaster. But we know this is the right way that we're going to be moving. We don't want to have this closed internal server anymore. We want to open it up to the developers worldwide because we know we're going to get better products made that way. And so now we have a little bit of time for questions. I know we went through a lot. Does anyone have any questions? Okay, I guess not. Well, thank you.